So one of the cool things that you can do with trig functions is fit them to data. And there's a lot of data that reflect periodic functions, such as the amount of daylight in a particular day at a certain location, or average temperatures, etc. So we're going to look at the latter for the first example, and we're going to try and fit a sine wave curve to that. Now what that's going to look like and entail is this. Our sine waves have this kind of a shape here, where this distance, say from top to bottom, right here, is twice our amplitude. This distance, or excuse me, half that distance is actually the amplitude. So this distance right here would be A. This distance here is kind of like the middle line. So it's the average of these 2 points. It's the average of the high and the low. So that's going to be your D there. What else do I need to adjust this? We've adjusted the amplitude and the height. Another thing we're going to need to know is the period of this graph. So the period is going to be how long it takes to get from one point to another similar point in that curve. What we're used to is that the period equals 2 pi divided by b, and that's great if you're trying to figure out the period, but if you're trying to figure out b, then it's going to be 2 pi divided by the period gives you b. So far that's 3 of the 4 different constants that we need to determine. We need to determine A, B, C, and D. The last thing to keep in mind is that C occurs, or excuse me, C is going to be adjusted so that our maximum height occurs at the right spot. And we'll do that one as we go through, but basically we want to adjust C so that this point happens at the maximum for sine. The maximum for sine happens at pi over 2. So we're going to adjust this expression and then solve for C based on the idea that it'll happen at pi over 2. Okay, so let's look at what we got going here. Here's all the data. Now I threw something in the chat with you, which plotted all this data in Desmos. And I apologize, I keep on using Desmos. I actually went a little bit further. Instead of just plotting one cycle, I plotted 2 cycles. So I went through the first one, and then I did another one. And that's just for visual effect. I just wanted to see things visually. So let's step back and take a look at things. So the lowest that the data gets is right here. That's the temperature in January. So I'll put this little line here on the bottom. That's that low temperature. Here's the high temperature, high monthly temperature. Wow. And we're complaining about what we went through last week. Alaska looks a little bit colder. That's okay. So let's start figuring out some things about this. For instance, maybe we can figure out what the height is for D. D is going to be halfway between the top line and the bottom line. So how could I figure that out? We could average those, right? You could take 24.6 and add 56.6 and divide by 2. That average will tell you this middle line here. So let's see what that average is. And let's see. That average is 40.1. So if I put in that line, y equals 40.1, there you go. That's my middle line. Great. So 1 down, 3 to go. Are we okay with this middle line here? The distance between this point here and my middle line, that is the top and the middle, that's going to be my amplitude. So in terms of figuring out my amplitude, I could just take 56.6 and subtract 40.1, and that's going to give me 16.5 for the middle line. Okay. Did I do that right? Is it 40.1? Oh, I'm sorry. This should be a 56.6, right? So yeah, 56.6. There we go. So 40.6, that looks a little bit better. So this distance between this line and this point here, that's going to be my amplitude. So let's take a look at what that's going to be accordingly. So 56.6 minus 40.6 is going to give me an even 16. So 2 down, 1 to go, or 2 down and 2 to go. So I've got A, I've got D. The next thing I want to figure out is B. Now B is going to be 2 pi divided by the period. But if we think a little bit, I'm pretty sure we can come up with the period. So what's the period going to be for us in this one? How long before this graph repeats itself or before it cycles through once again? I'll give you a hint. How many months in a year?
12.
12.
365.
That'd be if we were
working. That's how many days are in a year. 12.
So yeah, in months it'd be 12. So as far as B is concerned, B is going to be 2 pi divided by 12, or basically pi over 6. So that's 3 down and 1 to go. The last thing to figure out is what C is. And the way we can get at C is by realizing that when I plug in or when I graph my function, the maximum has to occur at a specific point. So I want the maximum to occur in what month? Where is the hottest temperature? What month of the year has the hottest temperature?
July.
Yeah, July. There we go. 7th month, 56.6 degrees. So that's going to happen when x equals 7. So let's see about solving there. So x equals 7. That's going to give us our hottest temperature. I know that B is 6, pi over 6. So it's going to be pi over 6. Well, actually, I should write it like this. Bx plus C. That's going to equal to pi over 2. That's what I want. Now I know the values of B and X. X is going to be 7, and B is going to be pi over 6, plus C equals pi over 2. That allows us to solve for C. I'll move this over the other side, so that's going to be 7 pi over 6 plus C equals pi over 2. C equals pi over 2 minus 7 pi over 6. And yeah, it's not necessarily very fun to convert to common denominators, etc. So I'm going to cheat here. I want to write this as some nice fraction. What I'll do is I'll factor out the units of pi, and I get 1 over 2 minus 7 over 6 times pi. And I'll just let my calculator do the rest here. So to plug that in, it's going to be 1 divided by 2, or 0.5, minus 7 divided by 6. Now I'm just going to keep the units of pi out of this for the moment. Then I can hit the math key and answer the fraction. Oh, that's negative 2/3. So negative 2 pi over 3 would be the final answer there. That would be C. So it would look like this, negative 2 pi over 3. And that's it. I've got A, B, C, and D. Now, if you wanted those exactly, we've got these numbers exactly. The good news for you is that some of your problems don't ask for things exactly. And if all they're looking for is just some decimal approximations from a regression, then you can do that. So it's use gaffering utility or scatter plot to draw the scatter diagram for the data of one period. In looking at this, let's take a look here. Let's look back at our graph. Let's see. Now, when you're doing this on my math lab, you can click these pluses and enlarge these graphs. But 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I'm thinking A looks pretty good, but I'll be honest, I didn't write down the answer or copy down the answer to this one. But remember, the maximum is going to occur in the 7th month. So looking at this one, maximum occurs in like the 6th month, or between the 5th and 6th month. So you can eliminate a couple of these things. Now, we found them exactly, but what if you're just asked to find this with a graphing calculator or something like that? In our case, I would suggest you do it with Desmos. Now, when you do this at home, what you can do is you can copy or type over the values in here and just run things at home like I'm running them here. You're going to run a regression. And I've actually already typed it in for you. It's this right here. Y equals A sine BX plus C plus D. And it gives you all the values. You're just going to have to type in the new Y coordinates for your data, and it'll figure out the right answers. So there you go, A, B, C, and D. Looks pretty good. Now, if I were to graph that, I should be able to turn that graph on. No, I don't have it typed in. So I'll type it in. Y equals A, which is 15.6, 5, sine of B, which is 0.517 x, plus C actually should be minus 2.088, and then plus D, which is 40.8. So there we go. Pretty good fit, I'd say, overall. I think it's a really good fit for the data. In fact, if you take my statistics class, you'll realize that, well, let's see, it's not showing us a value of R squared, but our value of R squared would be really, really high. Okay, let's do one more like that.
I have a question.
Ace.
So when you were solving for C, why did you set BX plus C equal to pi over 2?
Great question. Let me give you an answer. So for that, let me just remind you of the graph of the sine function. Come on, there we go. Y equals sine of x where does this maximum point occur at? You remember? Where's the sine going to be its biggest? So you start out, sine of 0 is 0, and then sine of, say, pi over 4 is square root of 2 over 2. But what value, what angle is this one on the x-axis? Do you remember what it is?
Pi over 2.
Pi over 2, yeah. So I know that the maximum has to occur at pi over 2. So what we did was we said, you know what? We're going to reverse engineer this. I want to know for my values, when does pi over 2 occur? And I know it occurs in this data set when x equals 7, that is July. We'd already solved for B. So plugging in that, I solved for C. Okay. If likewise, if you're welcome. If you had, say, not the maximum, but the minimum, then you can do likewise. You plug in whatever value of x gives you your minimum, and the minimum that the sine graph would be 3 pi over 2. So you could solve for things that way. So here's 3 pi over 2, then the sine graph is -1. So that's another way you could solve for C. It just depends on what data you have. Okay. Thanks for the question. All right. Any follow-up on that one? All right. So let's do one more, like the one we just did, where we're going to calculate the equation that fits our data. So in this case, we want to come up with an equation in this form: y equals sine bx plus c plus d. Now applying that to this particular problem, which represents the heights of high tide and low tide, one of the first things that I see is that it's 12 hours and 28 minutes between high tide and low tide. According to the National Oceanic and Atmospheric Administration, on a particular day, high tide occurred at 12:28 a.m. That's 0.47 hours, and low tide occurred at 7.07, or 7.12 hours. Water heights are measured in the amounts above or below the mean lower low water. The height of the water at high tide was 5.86 feet, and the height of the water at low tide was 0.04 feet. So let's start with those last two numbers. The high tide and the low tide, 5.86 and 0.04. So let's put those numbers here in terms of y heights, high tide, low tide. So this middle number here is going to be our D, and D is really going to be the average between these two. So it's going to be 5.86 plus 0.04 divided by 2. So 5.9 divided by 2 is going to be 2.95 for D. So D is done. What about A? A is going to be the distance between this middle line and the high tide, or the middle line and the low tide. Now, I know it doesn't look good on camera, but these are actually identical distances. This one might appear shorter. In any case, this distance is really going to be 5.86 minus 2.95. And that distance is going to be our amplitude. And that distance is going to be, let's see, 2.91. Yeah. So there's your D and there's your A. There's a couple other things we need to figure out. The next thing I'll work on is B. So the period is going to be 2 pi divided by B, or if we turn that around, an equivalent relationship is that B equals 2 pi divided by the period. And in this case, they tell us the period. The period was told to us as 12 hours 12.47 hours. So 12.47. And we'll divide that into pi. Do that on a calculator. Actually, I said divide it into pi. We should divide it into 2 pi. 2 pi divided by 12.47. About 0.504. So we'll go with it there. 0.504. So now we've got 3 down. We've got D, which is here. We've got A, which is here. And now we've got B, which is there. The only thing left we need to figure out is what C is. So let's see if we can't figure out what C is. The thing that I'll have you note in determining C is that the maximum of a sine function is going to occur at pi over 2. So we want to figure out when does bx plus c equal pi over 2. And we actually know some of this stuff. We know that, for instance, b is 0.504. And they tell us when the maximum value occurs, that is, when high tide occurs. So let's look back at the problem for that. High tide occurred at 12:28 a.m., about 0.47 hours. So I'll put that in as my value for x. 0.47. And then just solve for c. C is going to be pi over 2 minus 0.504 times 0.47. And that should give me my value for c. Going to bust out the calculator one more time. So pi over 2 minus 0.504 times 0.47. So about 1.334. And that's it. That's the last of our values. So let's figure out what the final equation is going to look like. That's going to be y equals 2.91 times sine of 0.504 times x plus 1.334 plus 2.95. And now you can use that equation to make predictions. I think they ask you to make prediction. You're just going to type in the value of x that represents what time you need here. So let's look back at the, this is approximately when will the next high tide occur. So there's probably a couple ways you can do that. One would be to figure out 12 hours and 28 minutes from when the last high tide occurred. That's probably the easiest way to do it. You could also figure out the height of the water at 6 p.m. by plugging in the x that corresponds to 6. Make sure your calculator is in radian mode, and you'll pop out with 0.993.